Hey everyone, my name is Ajay, and in this section we are going to talk about Azure Transit VNet and user-defined routes. Let's talk about hub to spoke transit connectivity. So on the slide you can see this is VNet 1 where my customer is connected, and this connectivity can happen over the express route, which is going to be the private circuit, or on point-to-point IPsec connections. These connections will be terminated on the gateway subnet. Now I have a spoke 1 which is connected to vNet 1, and this is vNet peering. This spoke 2 is located in a different region, so this is a connectivity vNet peering which we call the global vNet peering, and I have a spoke 3. This is also a vNet peering. Now if I say this is A, this is B, this is C, I have connectivity from A to B, B to C. It does not mean I can talk directly from spoke 1 to spoke 2. By default, this is not allowed. Now, when we provision a express route of circuit, I need to choose VNet where you are going to have the gateway subnet. So this VNet, technically by design, this VNet we want to act as a hub. I have this connectivity and I want to access spoke 1, spoke 2, spoke 3 from here. So this becomes a hub, basically, hub transit. Now let's talk about spoke to spoke connectivity. If I want to talk to spoke 1 to spoke 2, I can create a additional pairing and I can talk to host between spoke 1 and spoke 2. Very similarly, if I deploy a spoke 3, I need to have a connectivity from spoke 1 to spoke 3, spoke 3 to spoke 2, and spoke 3 to my VNet. If it is in a full mesh fashion, they can talk to each other, but by default, they are not transit. So I need to do some extra provisioning to make one of the VNet as a transit. So I don't need these additional pairings. To do this exercise, we are going to use the topology, which you can see on my screen. This is vNet 1, which is my hub location. vNet 2 is going to be the spoke 1, which is located Central India. vNet 3 is a spoke 2, which is UK West. I'm going to use already provisioned resources. These are the vNet pairings and the gateway, which we have already done in my previous exercise. Let's validate our peering status. So I'm inside vNet 1 in peering section. I can see my vNet 1 to vNet 2 peering is connected and my gateway transit is disabled. My vNet 1 to vNet 3 pairing is updating because I've deleted the old configuration and created a global pairing between the vNet 1 and vNet 3. Here also my gateway transit is disabled. Let's validate once these vNet pairings are up how the connectivity looks like. So this is a machine vNet 1, which is we call app Unix 1, and the IP is 10.10.4.4. My app, my Unix 2 machine does reside inside the vNet 2, and the IP is 10.34.4. My third virtual machine is app Unix 3, is part of the vNet 3, and the IP is 10.44.4. So when I ping from vNet 1 to these IP addresses, I'm successfully able to ping both of them. And when I try to ping an IP address of the vNet 3 app Unix 3 from the app Unix 2, it fails. And that is the expected behavior. Whenever we provision some of the resources or maybe the VM on the Azure, there's going to be the effective routes applicable to that particular host. So let's verify how the routing looks like on app Unix 3. Those are called the effective routes. I'm inside app Unix 3 machine, and you need to go to the networking section and choose the NIC interface card. Under that, you can see a tab effective routes. When you click here, you can see these many routes. The routes with next hop none, they are kind of the inactive routes. So there is a one route which we can see is towards the internet. So this is the prefix is going to be 000/0. It means if the route does not exist within the routing table, by default you are going towards the internet. There's another route which you can see is vNet global peering. We are inside app Unix 3. It means we are looking at the routing table at the host, which is part of the vNet 3. And from vNet 3, I have a global peering to vNet 1. And this is the subnet or the network for the vNet 1, which is 10.10.0.0/16. Then I'm going to have the connected network as well, and this is the subnet or the IP ranges we allocated for the vNet 3, which is 10.40.0.0/16. Let's verify the routing table at app Unix 1, which is part of the vNet 1. If you go to the effective routes, you can see there's a routing table. So from here, we can see there's a one route towards the internet. There's another route, which is your connected network route, which is 10.10.0/0.0/16. Then I have two peerings. So my first peering is vNet peering, which we call the regional peering. It is going to vNet 2. And then I have a global peering to vNet 3. And my route is 10.40.0.0/16. Let's talk about how we can make hub vNet as a transit vNet. See, in my previous video, you have seen whenever we are connecting the vNet to vNet peering, this gateway transit is disabled. That means by default, these vNets, they are not going to act as a gateway transit. The connectivity between my hub to spoke are showing as connected. If you can recall, whenever we were provisioning vNet to vNet peering, we were always choosing the option none, which is by default. And that is the reason that transit gateway is coming as a disabled. So in my lab, we need to go and make the vNet as a hub and transit. So you need to choose the option, use this virtual network gateway or route server. I have already done it for my both the connectivity, which is vNet 1 to vNet 2 and vNet 1 to vNet 3. And that is how we are seeing that transit gateway is coming as enabled. Let's talk about the UDR, which is nothing but the user-defined routes. So we have seen there are routes get automatically provisioned as a part of the routing table of the host. So UDR gives us a flexibility if you want to do a override of routes. Maybe something is pointing towards the internet, but I want to send it to somewhere on maybe on the firewall. Then I need to create the routing table and apply that UDR table to that particular subnet. So let's see how do we create the routing table. You need to go to the resource, choose the route table, and in the route table you are going to see options to hit the create button. You can choose it from here. You can also choose it from here. As of now, there is no routing table to display since we never provisioned any of the routing table resources. I have already given or created two UDR tables. One is vNet 2 UDR, another one is vNet 3 UDR. And I've given the name like this so I can recall it. This is a UDR which is going to applicable to vNet 3, and this is the UDR which is going to applicable to vNet 2. So we can look at the property. The moment you hit the create button for the route table, you need to choose your subscription. This is my default subscription. If you have multiple subscription associated with your credentials, you can choose it from the drop down. You need to give the resource group. I'm going to use the same resource group. We need to keep in mind these routing tables are tied with the region. So my route table for vNet 2 as Central India, because I already provisioned vNet 2 in Central India. Now there's an option propagate gateway routes, yes or no. So there can be a connectivity from the express route to on-prem, or you might be running BGP on point-to-point. And if you want to propagate out the route, all the routes learned from on-prem to Azure to all these subnets, choose yes. If you don't want to pass those routes learned from the on-prem to subnets, choose no. Once you hit the create button, it is going to validate the resources you are going to provision. In this case, for vNet 2 UDR, my validation is passed. I need to hit the create button again so that it can provision my resources. Let's verify the routing table we created. So far we created vNet 2 UDR, vNet 3 UDR. My resource group is same for both. My location for first UDR is Central India and the second UDR is UK West. They are part of the same subscription. Once your route table is created, we need to add the routing prefixes with the next hop. So I'm inside the vNet 2 UDR. You can go to the routes, and from when you click on the routes, and you're going to see the options to create the routes. So we can see when we hit on the routes, there's an add button comes. When you click on that, you're going to get the fields where you can add the prefixes. When we click on the add route, since we are under the vNet 3 UDR, I need to give the name to that particular route which I want to add. I need to define the network ranges where I want to reach, and then I need to define the next hop type. In this lab, I do not have any virtual appliance, so I'm going to use or consider my gateway as a virtual appliance. So I'm going to use a virtual appliance to define my next hop. Let's do a route validation. So I'm under vNet to UDR, and here I can see my route name is to vNet 3. Means from vNet 2 I want to reach vNet 3. My address prefix is going to be the vNet 3 range, which is 10.40.0/16. My next hop is going to be the virtual appliance. So we don't have any real virtual appliance here, but I'm considering my gateway as a virtual appliance. And the next hop is going to be 10.10.2.4. My gateway resides in a range of 10.10.2.0/24, and I already discussed that whenever you provision the network gateways, there are going to be the VMs which automatically get created. So this is going to be the first IP which get assigned to those VMs. So my first three IPs are reserved. So this virtual gateway VM will get the first IP address 10.10.2.4. Similarly, when we inspect the vNet 3 UDR routing table, so I can see I mentioned to vNet 2, that is a route name. My address prefix is 10.30.0.0/16. Next hop type is virtual appliance, and this is the same IP as we have given for my previous route. Now it's time to associate those UDRs to a subnets. So UDRs basically you need to apply to the subnets, not to actual VNets. So I'm part of the VNet 3. When I click on the subnet, this is my application subnet. When I click on that,
here's the option to apply the route table. The route table is specific to the subnets. As of now, it's none, but I'm going to choose vNet 3 UDR and hit the save button. Similarly, I'm going to apply vNet 2 UDR to application subnet, which is part of the vNet 2. So inside vNet 2, go to the subnets, go to the application where I want to apply the UDR. So this is my application subnet, and the range is 1034.0, and this is the route table, vNet 2 UDR. Hit the save button. It's time to test our connectivity. So this is app Unix 2, which is part of the vNet 2. If I ping a app Unix 3 machine, I'm able to see the response coming now. Similarly, if I log into app Unix 3, I can ping the machine which is part of the vNet 2. So I have a connectivity between spoke to spoke now. And when I do the trace route, I can see all my traffic is first getting redirected to gateway, which is 10.10.2.4, and then it goes to spoke. Very similarly, when you test it from the vNet 3, you can see the same results. Now, after applying the UDR, let's test how it affects the routing table on the host. So I'm inside the app Unix 1. This is my network interface. If I go to the effective routes, I can see there's an internet route, there's a virtual network, there's a one vNet peering, which is the regional peering, and this is my global peering. So technically, we have not applied any of the UDR on the vNet 1, so there is nothing got changed. Let's verify the routing table on the app Unix 2. Same steps, go to the interface, go to the effective routes, and I can see there is a one route towards the internet, and there is a one for vNet peering, and this is my connected route. I can see something newly got added, and this is the UDR which we created. So from vNet 2, I have created a UDR which forwards my traffic to vNet 3 with the next hop 10.10.2.4. Similarly, let's inspect the routing table of app Unix 3. So here also we can see there's a user-defined route which got added. It is pointing towards the vNet 2 with the next hop 10.10.2.4. Let's recap now what we have done so far. So I have add a vNet 1 which we wanted to act as a hub. Since I don't want to provision a separate peering between spoke 1 to spoke 2. So all my traffic from spoke 1 it should go to vNet 1, and from vNet 1 it should go to the spoke 2. So vNet 1 should act as a transit. To do this activity, what we have done, we have already had a gateway provision, and the IP is going to get assigned to this gateway is going to be 10.10.2.4. Now I need to create the UDR. This UDR I'm going to apply to subnet from where I want to test. So I have a Unix machine which is part of the application. Similarly here, the Unix machine is a part of the application subnet. Once this UDR is applied, it is going to force traffic between these two subnets to gateway. So from gateway, it goes to the application now. These are the pairings, those were already established. So far the exercise, what we have done is just for the testing purpose, since we didn't have any NVA solution implemented. But if you go for and search in marketplace, you're going to find a lot many solutions which gives you the network virtual appliance. Those can be firewalls basically. And when you want to do very similar setup in production, probably you want to use the NVAs.
So this is the design from the Palo Alto. You can see instead of routing traffic from the gateway, the traffic will be routed from the firewalls. You're going to have the spoke 1, you're going to have the spoke 2, and my east-west traffic, which is connectivity, is based on the vNet peering, but my traffic from these subnets, it goes to these NVAs and it comes back to the spoke again. You can also implement Azure firewalls to achieve the same sort of the connectivity. So this is my hub, this is my spoke, this is my spoke. So when I want to talk to a spoke to spoke, my traffic is routed from the transit hub, and you need to implement these Azure firewalls as a part of the NVA solution. Thank you for watching. I will see you in the next video.